This is lesson 3-4 notes over writing and solving multi-step equations. So very similar to the lesson 3-2 notes. Right? Today we just add a step. So it says you can represent many real-world problems using multi-step equations using the following steps. So step 1 is the same as 3-2. We assign a variable to the unknown in the situation. When we know what we're looking for, we translate the words in the problem into a mathematical equation using our variable and keywords and phrases for mathematical operations. Okay, step 3 is to solve the equation, and then step 4 is to writing the answer in words. All right, so it says write and solve an equation for each of the following. Number 1, at the fair, Hunter bought 3 snacks and 10 ride tickets. Each ride cost $1.50 less than a snack. He spent a total of $24. What was the cost of each snack? All right, step 1, okay, is assigning a variable to the unknown. Since we are asked what the cost of each snack is, that is going to be our unknown. Now, I didn't move up yet because I have already started step 2 as well. All right, but what I would do for number 1, since we're looking for the cost of a snack, I would use C to represent the cost of each snack. You need to clarify because we're dealing with multiple costs here. So we're going to specify that C is the cost of a snack. So if you wanted to use S, you could do that as well, but remember that we're not looking for the number of snacks, we're looking for the cost of a snack, all right, because that's the question. All right, so step 2, translating the words in the problem into a mathematical equation. So here, I'm going to go up all the way. It says, at the fair, Hunter bought 3 snacks and 10 ride tickets. So the 3 snacks, the money that he spent on the 3 snacks and the 10 rides, okay, spent a total of $24, so that's going to be equal to $24. Then I break it down a little bit more. So it says, at the fair, Hunter bought 3 snacks and 10 ride tickets. Each ride cost $1.50 less than a snack. He spent a total of $24, so what was the cost of each snack? So we've got the 3 snacks and the 10 rides for $24. Okay, so the costs of the snacks. So let's say that the cost of each snack was $1, and he buys 3 of them, then he's going to spend $3 altogether. If the cost of each snack is $2 and he's bought 3, then he'd be spending $6 altogether. So we just multiply the number of snacks that he bought by the cost of each snack to see how much money was spent total. Okay, now we're going to do the same thing with the rides. Each ride costs a certain amount of money. Okay, that amount of money, it says that each ride costs $1.50 less than a snack. All right, so that's what I've written down. $1.50 less than the cost of a snack is the cost of a ride. So from here, I can break this down a little bit more. So I've got 3 times the cost of each snack, but we've identified that the cost of each snack is going to be C. So for this entire part, that's going to be 3C. Okay, plus 10 times all of this. Now, because there are 2 pieces of information in here, I'm going to put this in parentheses. Okay, the cost of each snack, again, we know is C. All right, but remember that the rides are $1.50 less than C. So I'm going to take away 1.5, and then that's going to equal my $24. All right, so this, I'll kind of clarify, okay, is all right here. Okay, and then my total is $24. So when I'm setting up an equation, a lot of times I want to find either the total, or if I'm told that 2 things are the same, then I know I'm going to set them equal to each other. If I'm given a total, I know that that's just going to be equals my total, and then I have to determine, okay, what makes up my total. So in this case, it was the cost of the 3 snacks and the cost of the 10 rides are going to make up that $24 altogether. That's how I kind of come up with this equation. All right, so step 3 is just to solve the equation. So this is step 3. I've got 3C plus 10 times C minus 1.5 equals 24. All right, I'm going to move over a little bit. My first step when I'm solving equations is to get rid of parentheses. So the 3C comes down, the equals 24 comes down. All right, but this positive 10, I'm going to distribute it to the C and to that 1.5 that's being subtracted. Remember, when we distribute, we multiply. So positive 10 times C is positive 10C. Positive 10 times a negative 1.5 is a minus 15, and then I go from there. All right, so step 2 is combining like terms. Okay, I'm going to look at both sides. On the left side, I've got a 3C and a 10C. Because they're on the same side, we just combine them. So those 2 together are 13C. My minus 15 comes down, my equals, and my 24 comes down. From there, right, I've got the variable on the left side, so my constants are going to move to the right. So to get rid of that minus 15, I add 15. That gives me 13C equals 39. All right, I would divide both sides by 13, not C, just 13, so that my C stays. And 39 divided by 13 is 3, which means the cost of each snack is $3. So when we write that in words, we would say, this is step 4, the cost of each snack is $3. And so what that means, so the cost of each ride is the cost of each snack minus $1.50, $1.50 less than the cost of each snack. So if the cost of each snack is $3, then the rides, 3 minus $1.50, means that each of the rides cost $1.50, because 3 minus 1.5 is also 1.5. All right, so that's something that you could find based off of the information that we were given as well. Okay, let's look at number 2. Number 2 says the hallway in Oscar's house is in the shape of a rectangle. The length of the hallway is half a foot longer than twice its width. The perimeter of the hallway is 31 feet. What is the width of the hallway? So we're trying to find the width. All right, so I'm going to say W is going to represent width. That's step 1. Identify your unknown and assign a variable to it. Okay, now we know that we're also talking about length. Okay, and that perimeter, we're given the perimeter is all the sides added together. So width plus length plus width plus length. All right, we actually have a formula for that. Our formula that we're going to use is perimeter equals 2 times the length plus 2 times the width. All right, because 2 times whatever L is plus 2 times whatever W is going to be all the sides added together. So when I set this up, my equation is going to be a little bit simpler because I have a formula, and we're going to give you that formula. Okay, 2 times L plus 2 times W. Let's go from here and see what we can replace. All right, so I go back to the problem. I'm looking for either the perimeter, the length, or the width. But I know it can't be width because that's what I'm trying to solve for. So I have to replace the P and the L with something. All right, so number 2 says the hallway in Oscar's house is in the shape of a rectangle. The length of the hallway, so this is L, the length of the hallway is half a foot longer than twice its width. So that's a lot of information, but that's okay. The perimeter of the hallway, so P, is 31 feet, which means I can replace this P with the 31. Okay, and then I also know the length, so I can replace the length, right? But I'm going to erase this, okay, so that I can write the length, and then you can't forget to add back that 2W at the end. So right now, I've got perimeter equals 2 times the length. Okay, and I'm going to put this in parentheses, and that's just because I'm multiplying. So 2 times the length, and the length is all of this, half a foot longer than twice its width. All right, so our length, I'm going to write this over here, is half a foot more than whatever twice its width is. So twice its width, when you have twice the amount of something, you're doubling it or multiplying it by 2. So twice its width is just 2W. Because it's half a foot more than 2W, I'm going to add that half a foot to it. And that is what I plug in for L. Because that's our length. Half a foot more than twice its width. All right, and then don't forget, got 31 equals 2 times the length, but I can't forget to write that plus 2W either. Okay, this makes sense. I'm trying to figure out what W is, so W can be the only variable that I can see in here. You will never have an L and a W at the same time and try to solve for one of those variables. Okay, not yet. So now we solve. 2 times 2W is 4W. 2 times 1/2 is 1. And I just bring down that plus 2W. Okay, from there, I notice that on the left side, there are no like terms. There's only one term. But on the right side, there are 2 variable terms. I've got a 4W plus a 2W. So when I simplify, I just put those together, I combine them, so I add them. 4W and 2W is 6W. Okay, and then I'm going to bring down that plus 1. From there, the W is on the right side, so I'm going to get my constants over to the left by taking away 1. And what I do on one side, I do on the other. Positive 1, negative 1 cancel. 31 minus 1 is 30. Okay, and then I bring down that 6w. All right, and from there, I divide both sides by 6, just 6. That way w stays here. And 30 divided by 6 is 5. We were looking for the width. All right, so the width or length is probably going to be measured in feet. Okay, look up here. There it is. It's measured in feet. So we're going to say that the width of the hallway is 5 feet. And then you could also figure out what the length is, okay, once we know what the width is. So 2 times the width plus 1/2. That just means that the hallway's length is going to be, let's see, 2 times 5 is 10, 10 plus 1/2. It would be 10.5 feet for the length. Okay, and then to double check, make sure that you did it correctly. You don't have to do this, but if the length is 10.5, so both 10.5, and the width is both 5, okay, well, 10.5 plus 10.5 plus 5 plus 5 is going to be equal to 31. That means that we did the problem correctly because the perimeter should add up to 31 feet. Okay, let's look at the back. All right, on the back, number 3 says Cora and Penelope are participating in a fitness program. Part of the program includes walking, while the other part includes running. Cora trains for 5 weeks, while Penelope trains for 6 weeks. They each walk the same number of miles per week and complete the same number of total miles in total during their training. In addition, Cora runs 3 3/4 miles per week, while Penelope runs 2 miles each week. How many miles does each person walk per week? All right, so we've got walking miles and running miles. So I'm going to say, because the question is how many miles, okay, does each person walk, I'm going to use M to represent walking miles. Okay, and then I would break this down before I even try to set up the equation. Let's write down, so I'm going to say Cora and Penelope. And I'm just going to pull out some information because this is a lot. All right, so Cora, we know that she trains for 5 weeks, so in 5 weeks, this is what she does. Okay, and Penelope trains for 6 weeks, so in 6 weeks, we're going to see what she does. Okay, so it says they each walk the same number of miles per week and complete the same number of total miles. So it's telling us, the problem is telling us that Cora's miles altogether are going to be, let's see, what does it say? It says they each walk the same number of miles per week and complete the same number of total miles during their training. So Cora's miles are going to be the same as Penelope's miles. Okay, and so I need to figure out, it says that they each walk the same number of miles per week, so we don't know the walking miles. But we know they walk the same, so we can put the same thing down for each of them. Let's see how many miles they run. Okay, it says they each walk the same number of miles per week and do the same number of total miles. In addition, Cora runs 3 3/4 miles per week, so let's change that into a decimal. Say 3.75 miles are ran. Either way. Okay, and then let's see, while Penelope runs 2 miles. So all together, they're going to run the same amount. Here's how I would set this up. Cora's miles are going to be set equal to Penelope's miles. So for Cora, we know that she trains for 5 weeks and Penelope trains for 6 weeks. Okay? In each of those 5 weeks, so this is what she's going to do each 5 weeks, there's walking miles. Okay, well, we don't know the number of walking miles, but we have a variable to represent that. So there's walking miles plus the 3.75 miles that she runs. Okay, for Penelope, she trains for 6 weeks, and each week, all right, so what's in parentheses represents 1 week. All right, but we have to multiply that by 5 weeks for Cora, okay, and by 6 weeks for Penelope. So Penelope walks in miles, because we don't know, Okay, and she runs 2 miles. So our equation, okay, this is how we're going to set it up, and I won't rewrite it even though it's spaced a little bit. I'll just move my equal sign over a little bit. Okay, and then we solve. Okay, so one more time though, Cora's miles set equal to Penelope's miles. Okay, the total number of miles per 1 week, and then I multiply that by the number of weeks that they train, so times 5 for Cora. Okay, Penelope times 6 for Penelope. All right, so here's what I'm going to do. I'm going to start solving this equation. I'll do it in a different color by distributing. All right, we've got the 5 that we multiply by m and by 3.75. 5 times m is 5m. 5 times 3.75 is going to be 18.75. And that's going to be set equal to Penelope's miles. So 6 times m is 6m. And 6 times 2, positive 2, is 12. Okay, and now I can solve for m, the number of walking miles. All right, so let's see. We've got 5m and 6m. I would start by taking away the 5m from both sides. Okay, 6m, let me back up. Step 1 was getting rid of parentheses by using the distributive property. I skipped to step 3 because step 2 is combining like terms on each side, and we can't combine these. We can't combine these. That's why I jumped to step 3, because step 2 we just can't do on this problem. All right, so now step 3. 6m minus 5m is 1m. Okay, I'm going to bring down the plus 12. I'm going to bring down the equal sign and the 18.75. All right, and then I'm going to subtract 12 from both sides. 12. 18.75 minus 12 is going to be 6.75. And that is equal to m, and that's it. That's all we had to do. So I'm going to write underneath this. I'm not going to write it out on words. You can leave it here. Just don't forget your unit. Okay, this represents that each of these girls walks 6.75 miles each week. So we're going to say walking miles because they walk the same amount. It's that amount of miles per each person. All right, and that's it for number 3. Okay, let's look at number 4. It says the table shows the number of woodwind instruments in Kaylee's band class. What is the ratio of the number of saxophones to the number of flutes if the total number of instruments is 3x plus 1? Write your answer in simplest form. All right, so we want to know the ratio of the number of saxophones to flutes. Okay, so we know that flutes represent x, okay, and we know that saxophones are represented by 2x minus 6, but in order to figure out what that ratio is, we need to know what x is. All right, so here's what we're going to have to do. We know that the total number of instruments is 3x plus 1. So 10 plus x plus all of this is going to equal 3x plus 1. All right, so here's what we do. We set it up. All right, and I'm going to move down a little bit. I'm going to do 10. I'm going to write it horizontally. 10 plus x plus 2x minus 13, in parentheses, plus 2 times x minus 6, and that's all equal to 3x plus 1. All right, so I added all the instruments together to get my total, and now I have to figure out what x is. All right, so first, we do whatever is inside parentheses so we can simplify. So this is going to be 10 plus x. All right, and then since this is a positive sign in front of the parentheses, we can just drop the parentheses. If there's a negative sign here, we'd have to distribute the negative. But when we distribute a positive, we just still get a positive 2x. And adding a negative 13 is still just a negative 13. So we drop the parentheses. Okay, and then here, this is positive. Let's see, so we've got plus 2 times x minus 6. So I have to distribute. Okay, 2 times x is 2x. So there's a plus sign here. Okay, 2x. 2 times negative 6 is negative 12. Okay, but again, because there's a plus sign in front of these parentheses, I can just drop the parentheses. Okay, and that equals 3x plus 1. So it looks like a lot, but all we're going to do is combine like terms, simplify this. So we've got a positive 6 and a positive 2x on the left side. We've also got a positive 2x here. So we've got 2 plus an invisible 1. So my x's are all going to simplify to 5x. All right, and then I've also got this 10, negative 13, and negative 12. So 10 minus 13 is going to be negative 3. Okay, negative 3 minus 12 is going to be negative 15. Okay, and then equals 3x plus 1. Nothing to simplify on the right side. So now I get my variables together and my constants together. So I would start by subtracting 3x from both sides. 5x minus 3x is 2x. Bring down my minus 15, my equals 1. Okay, from there get my constants together. So I'm going to add 15 to both sides. That gives me 2x equals 16. And then the last step, divide both sides by 2. And x equals 8. Which means if x is 8, my number of flutes is 8. And then my number of saxophones is 2 times whatever 8 minus 6 is. 8 minus 6 is 2. 2 times 2 is 4. So my ratio of saxophones to flutes is 4 to 8. All right, but we can simplify this and say 1 to 2. All right, and that is our actual answer. That concludes our notes for today.